Okay, so get this. You know how quantum computing is supposed to change everything?
Yeah.
Well, imagine building those quantum computers with molecules,
Wow.
the same kind that make up, everything around us.
Right.
That's what we're diving into today.
Okay.
It's this breakthrough using light to make molecules practically dance in a way that could revolutionize technology.
I like that.
And it's all thanks to a brand new article in Nature
Oh, wow.
from January 15th, 2025. So we're talking cutting-edge science here.
Yeah, it really is remarkable. What we're talking about here is manipulating matter at the most fundamental level.
That's incredible.
Imagine a molecular ballet
Oh, I love that.
choreographed with lasers.
But first, for anyone who needs a refresher, let's talk about quantum entanglement.
Right.
It's still mind-boggling even to scientists.
It really is essentially two particles become so deeply linked that they affect each other instantly no matter how far apart they are. It's like they have this secret instantaneous communication channel completely defying the usual rules of physics.
Right. It's like they're twins who can always feel what the other is experiencing, even across galaxies.
Yeah.
Scientists have been able to entangle atoms for a while now, but this research takes it up a notch using molecules.
Okay.
Now molecules are way more complex than atoms, opening up a whole new realm of possibilities.
Think of it this way. Atoms are like the basic building blocks,
Right.
while molecules are like intricate structures built from those blocks.
Yeah.
So by entangling molecules, we're essentially creating more sophisticated building blocks for quantum technologies.
Oh, that's a great way to put it. So how do they pull this off?
Well,
Tell me about these magic-wavelength optical tweezers.
okay, so think of them as incredibly focused laser beams,
Okay.
like tiny tractor beams.
Wow.
They can trap and move individual molecules with incredible precision.
So it's like having microscopic fingers that can not only grab these tiny molecules, but also make them interact in this special entangled way.
Precisely, they're manipulating those molecules at the quantum level.
That's amazing.
And the truly groundbreaking part is that they managed to create entangled molecules that stayed entangled for almost a whole second.
A whole second? That doesn't sound that long.
It's an eternity in the quantum world.
Oh.
Before this, scientists could only entangle molecules for incredibly short periods. This breakthrough means they can actually manipulate those entangled molecules for long enough to do something useful with them.
That's huge. So tell me, why is this long-lasting entanglement such a big deal?
Whoa.
Why should we care about molecules doing their quantum dance for a whole second?
Okay, good question.
What does it actually allow us to do?
For one, it opens the door to building more complex quantum operations.
Yeah.
Think about it. The longer the entanglement lasts, the more time you have to perform those intricate quantum maneuvers,
Right.
getting us closer to building quantum computers that can tackle problems far beyond even the most powerful supercomputers we have today.
So it's not just about entangling the molecules, it's about keeping them entangled long enough to actually put them to work.
Exactly. And it's not just about computing power.
What else?
Think about incredibly sensitive quantum sensors that could detect the slightest changes, like finding a single grain of sand on an entire beach.
Wow.
This kind of sensitivity would be groundbreaking for medicine materials. Science, environmental monitoring, the possibilities are vast.
Wow, it sounds like this discovery could change everything. Okay, so tell me more about what this team at Durham University actually achieved.
Okay.
What were the specifics of their success?
They were incredibly precise. They achieved an entanglement fidelity of over 92%,
Okay.
which basically means the entanglement they created was incredibly reliable and stable.
So they were able to reliably create these entangled pairs of molecules over and over again.
Yes. And what's even more promising is that they could reach even higher fidelity by accounting for certain correctable errors. Think of it like fine-tuning their technique. There's still room for improvement, meaning even greater precision is possible.
So this is already a huge step, but it sounds like it's just the beginning. What does this breakthrough mean for the future of quantum technology?
This research takes us closer to building quantum memories,
Quantum memory.
devices that can store quantum information for long periods.
Wow.
These memories are essential for developing more powerful quantum computers and even quantum networks.
Okay.
Think of a quantum internet.
Like the internet, but quantum.
It's like capturing that incredible molecular ballet on film so you can study every step in detail.
So we've talked about entangling the molecules, manipulating them, and now potentially storing that information.
Right.
It sounds like we're building up quite the quantum toolkit. This is where it gets really interesting. What are some of the potential applications of these quantum memories? What could we actually do with them?
Well, imagine a world where your online data is protected by the laws of quantum mechanics, making it virtually unhackable.
No.
That's the power of quantum communication networks, and quantum memories are crucial for making that a reality.
That's incredible. It's like having a code based on the fundamental laws of the universe.
Exactly.
But it's not just about security, right? What else could these quantum memories be used for?
This is just the tip of the iceberg. Quantum memories could help us build larger, more powerful quantum computers,
Okay.
able to solve problems that are currently impossible for even our most advanced systems.
Wow.
They could revolutionize drug discovery, materials, science, and our understanding of the universe itself. We're talking about a whole new era of technology.
Okay, so we've covered a lot of ground here. We've talked about quantum entanglement, these amazing magic tweezers, long-lasting entanglement in molecules,
Right.
and the potential of quantum memories. It's mind-blowing stuff.
It really is.
But before we get too carried away, let's bring it back to our listener.
Okay.
What does all of this mean for you?
Well,
Why should you care about these tiny entangled molecules?
well, for starters, this research could lead to breakthroughs that touch every aspect of our lives.
Like what?
New medical treatments, more efficient energy sources, materials with unimaginable properties. It's like the butterfly effect. These tiny particles dancing in a lab could have ripple effects that change the entire world.
It's like we're witnessing the birth of a new technological era, one where the seemingly impossible becomes possible.
Yeah, and even if you aren't a scientist or an engineer, understanding these developments is crucial. This is the future unfolding before our eyes.
It's like being informed about the forces shaping the world around us.
Right.
Even if you don't understand all the details, it's fascinating to see how these discoveries could change everything.
Absolutely. And beyond the practical applications, there's the sheer wonder of it all. We're unlocking the secrets of the universe at its most fundamental level.
It's a testament to human curiosity and our drive to understand the world around us.
Yeah.
And it's a reminder that there's still so much we don't know. There's always more to discover, more to learn, more to explore. That's what makes science so exciting.
I agree.
But we'll dive even deeper into that after a quick break. Stay with us.
Yeah, definitely. So before we're talking about all the possibilities these quantum memories unlock.
Right.
But how do these magic wavelength optical tweezers actually create these long-lived entangled states?
Yeah, how do they actually do it?
What's the secret sauce?
Yeah, back to the science, if I'm understanding this correctly. These tweezers use a very specific wavelength of light,
Right.
hence the magic-wavelength part.
Exactly.
And this special light minimizes any disturbances to those delicate molecules.
You see, even tiny amounts of energy can disrupt entanglement.
Right.
Those delicate quantum connections.
Yeah.
It's like trying to build a house of cards in a hurricane.
Oh, I see.
The researchers needed to create an incredibly stable, calm environment.
Okay.
These magic wavelengths act like a shield, minimizing the light's interaction with the molecules, letting them maintain their entanglement for much longer.
So it's like finding the perfect quiet spot where the molecules can just hang out and stay entangled, undisturbed by all the chaos of the quantum world.
A perfect analogy.
I like that one.
And that's where the team's expertise really shines.
Okay.
They had to carefully tune those laser beams to hit that exact sweet spot,
Right.
that magic wavelength.
It sounds insanely complex, like trying to hit a bullseye on a target the size of an atom.
Yeah.
So let's talk about the molecules themselves.
Okay.
What kind of molecules were they using for this research?
They used a type of molecule called a diatomic molecule,
Diatomic molecule.
which, as the name suggests, is simply a molecule made up of two atoms.
Two atoms.
Specifically, they used rubidium atoms,
Rubidium atoms.
which are a favorite in quantum experiments because they have properties that make them easy to work with.
So they're using these incredibly precise laser tweezers to manipulate these tiny rubidium molecules and make them do their quantum dance, staying entangled for that record-breaking second.
Exactly. And the exciting part is this technique could potentially be applied to other types of molecules,
Oh, really?
opening up a whole new frontier in exploring and controlling quantum phenomena in more complex systems.
It's like having a master key that unlocks all sorts of new doors in the quantum world.
I like that.
It's not just about rubidium.
Yeah.
It's about the potential to apply this to a whole range of molecules, which could lead to even more mind-blowing discoveries.
Absolutely. And that's precisely where the field is heading.
Okay.
Scientists are already looking at ways to use these techniques to entangle larger, more complex molecules,
Wow.
and even create entanglement between different types of molecules.
Wait, are you saying we could have entangled states between molecules that normally wouldn't interact with each other?
Yes,
That's like making oil and water mix at the quantum level.
that's a great way to put it. It opens up a whole new realm of possibilities for designing and creating completely new materials with unique properties.
It's like having a set of molecular Legos and being able to create all sorts of crazy structures that were never possible before.
Right.
So with these magic wavelength optical tweezers, it seems like the possibilities are endless.
It seems that way.
But I'm sure there are still challenges, right?
Of course.
What are some of the hurdles that researchers still need to overcome?
Like with any groundbreaking scientific discovery, there are always new challenges to tackle.
Of course.
For one, scaling up this technology to entangle larger numbers of molecules is still a big hurdle.
Okay.
Right now, they've only managed to entangle 2 molecules at a time.
So we've mastered the tango, but we need to figure out how to choreograph a whole molecular ballet.
Exactly. Another challenge is maintaining that entanglement for even longer periods,
Right.
while a second is huge in the quantum world.
Yeah.
For some practical applications, we need to keep those molecules dancing together even longer.
So it's not just about getting them to dance, but getting them to dance together for a whole song, not just a few beats.
Precisely.
Yeah.
And these are just a couple of the many exciting challenges researchers are tackling. But the progress they've made in this field is truly remarkable.
Yeah.
We're witnessing a new era of quantum science unfold before our very eyes.
It's like we're watching the quantum world come alive with possibilities.
Yeah.
But as we explore these new frontiers, I think it's also important to consider the implications of this research. I mean, we're talking about manipulating matter at its most fundamental level.
Yeah.
That kind of power comes with responsibility, doesn't it?
That's an excellent point, and that's a conversation that's happening right now in the scientific community. As with any powerful new technology, we have to be mindful of both its potential benefits and any potential risks.
Right. It's like giving someone a powerful new tool without any safety instructions.
Yeah.
We need to figure out how to use this technology responsibly.
Absolutely. It's crucial that we have open and honest discussions about the ethical implications of these advancements,
Okay.
involving not just scientists, but also policymakers and the public. We need to work together to ensure that this technology is developed and used for the benefit of humanity.
So it's not just about the scientific breakthroughs, but also about the societal impact and how we as a society choose to use this technology.
Right.
It's about ensuring that we're using this incredible power for good and not for harm.
Exactly. And that requires a thoughtful, nuanced approach.
Okay.
We need to consider not just the scientific possibilities, but also the potential impact on society as a whole.
It's about making sure that this technology serves humanity and doesn't become something we can't control. We need to be having these conversations now before the technology is fully developed and out in the world. It's better to be proactive than reactive.
I completely agree. We need to anticipate potential problems and find solutions before they become major issues.
So it's about taking a holistic view, considering not just the exciting scientific progress, but also the ethical and societal implications. It's about making sure that this research truly benefits humanity.
Exactly. It's about ensuring that this powerful new technology is used to uplift and improve our lives, not to create new problems or exacerbate existing ones. It's about using this technology for good, for everyone.
I think that's a great place to wrap up part 2.
Okay.
We've covered a lot of ground, from the intricacies of these magic tweezers to the potential and the responsibility that comes with such powerful technology. But there's still so much more to explore. After a quick break, we'll be back to discuss the broader implications of this research and what it might mean for the future. We've talked about the science, the potential applications, and the huge responsibility that comes with this new technology. But let's just take a moment to appreciate how groundbreaking this research really is. We're talking about a whole new level of control over the building blocks of the universe.
Yeah, it really is a paradigm shift. We're no longer just observing the quantum world. We're actively manipulating it.
Wow.
To be able to control and manipulate individual molecules with this level of precision is astounding.
It's like we've been given this incredible toolkit for the quantum world. And the fact that we can create and sustain entanglement for so long opens up so many possibilities. It's like we've finally built a stable foundation for the quantum technologies of the future.
This research is really a testament to human ingenuity, and our endless curiosity.
It really is.
It's a reminder that we're constantly pushing the boundaries of what's possible.
Yeah.
And that the future is full of incredible potential.
And it's not just about the technology itself. It's about the spirit of discovery, the thrill of the unknown, the drive to understand the universe and our place in it. It's about pushing the boundaries of human knowledge.
Science is, at its core, a journey of exploration. And this research is a perfect example of that journey, showcasing the power of human curiosity and our ability to unravel the mysteries of the cosmos.
It's truly inspiring to think about what future generations will be able to achieve with the tools and knowledge we're developing today. What incredible discoveries are waiting just beyond the horizon.
The future of quantum technology is bright, and I'm incredibly excited to see what unfolds in the years to come.
Before we wrap up this deep dive, I want to leave our listeners with one final thought.
Okay.
We've talked about how these magic-wavelength optical tweezers can manipulate the quantum states of molecules, but could this lead to even more profound breakthroughs?
Like what?
Could we potentially control chemical reactions at the most fundamental level, atom by atom?
That's a fascinating question, and it's one that researchers are already exploring.
Wow.
If we can control the quantum states of individual molecules, it's not a huge leap to imagine orchestrating chemical reactions with incredible precision.
Imagine designing and creating entirely new materials with tailor-made properties, or even manipulating biological processes at the molecular level. The possibilities are truly mind-boggling.
It's a future full of promise for medicine, materials, science, and our understanding of life itself. And it all stems from our ability to manipulate matter at the quantum level, thanks to tools like these magic wavelength optical tweezers.
So as we conclude this deep dive into magic wavelength optical tweezers and the future of quantum technology, we leave you with a sense of wonder and a challenge. What other applications of this magic technology can you imagine? What world-changing innovations might emerge from our newfound ability to control the quantum world? The future's waiting to be discovered, and who knows, maybe you'll be the one to unlock its secrets. Thanks for joining us.